Jai Hind and welcome to all. Myself Shiwani. So, in this lecture, I will tell about the introduction of electrode potential and which is a part of Unit 3 Electrochemistry. The references which I have taken is from Engineering Chemistry, Jan and Jan, Engineering Chemistry by Shashi Chawla, and Wikipedia or www.jntu.ac.in. And the first, what is electrochemistry? So, electrochemistry is a branch of chemistry that examines the phenomena resulting from combined chemical and electrical effect. It means where we find the electrical energy from the chemical reaction, or we can say the electrical effect from the chemical change is known as electrochemistry. So, here chemical transformation occurring owing to the external applied electric current or leading to generation of electrical current which is studied in electrochemistry. So, in electrochemistry when we talk about this, so we use electrodes. So, electrodes they may be of two types, inert or reactive electrodes. So, inert electrodes are those type of electrode which do not react with the product produced or dissolve in the electrolyte, and generally carbon and platinum electrodes are used. While in this electrochemistry we use reactive electrodes, that is they can react or dissolve in electrolyte. We use copper, silver, mercury, zinc, etc. So, first is what is cell and what are the types of cell. So, cell which is used to produce electrical energy, and there are two types. First is electrolytic cell and second is electrochemical cell. In second, that is electrochemical cell, the chemical reaction or chemical energy is converted to electrical energy. That is the chemical reactions that result in production of electrical energy. And this is a galvanic and or voltaic cell is the example of electrochemical cell, and in this galvanic this cell converts chemical potential energy into this. So, the electrical conversion is achieved by the spontaneous reaction, and for spontaneous reaction we use term delta G, and delta G is the Gibbs free energy and delta G is less than 0. It means it is a spontaneous. While in electrolytic process, few electrical energy is required, that is in reactions in which the chemical changes occur on the passage of an electrical current. The electrolytic cells, they are driven by an external source of electrical energy. It means for a chemical reaction, first electrical energy is required. For example, in battery or when we recharge this, that is for the chemical reaction first charging is required. So, this is the type of electrolytic cell. So, flow of electrons drives non-spontaneous, that is delta G is greater than equal to 0 redox reaction. In electrochemical cell, generally cathode it acquire positive charge, while in electrolytic cell when the electrical energy is passed, it means the cathode has reverse charge, that is negative charge. So, in electrode or cell, there is a term oxidation and reduction, and when we remember the oxidation, please remember this word lone. So, lone is the L means loss of electron, O means that is it is a type of oxidation, and AN means it always occur at anode in electrochemical cell. So, the electrode at which oxidation occur is termed as anode. So, we can remember this point or the overall convention of the cell from this word. So, similarly, the electrode at which reduction occur, so it is cathode, it means gain of electron. And when we write the cell reaction, then anode it is right on left side and cathode it is right on right side. A cell operating spontaneously in this configuration is said to have total positive cell potential. And why this is positive for a spontaneous process? Because we know that the Gibbs free energy is minus NFE, and if E is positive, then we get delta G value less than 0, that is the reaction will be spontaneous. This is for basically electrochemical cell. And when it is connecting a voltmeter, the positive terminal to the positive electrode, and if it reads a positive potential, you have correctly identified all the terminals. Or if we read a negative potential, then it is not this, it means the basically there is a gain of electron, that is in galvanic cell or in electrochemical cell the cathode has positive, while in electrolytic cathode is negative. Now, before this let us take reduction potential, electrode potential. So, first is what is electrode potential? So, electrode potential we can find, let us show it. Okay. For electrode potential, when the metal rod is dipped in its solution or its electrolyte, let this is a M and the solution Mn plus. So, either it will gain the electron or lose the electron. Either it gain or loss, there will be a charge, it depends on its tendency, either positive or negative. And because of this charge, the positively charged ions, they will come towards this rod from the ions. So, at outer side there will be a charge of opposite ions, and because of this a potential difference will create, and this potential difference is called electrode potential, and this layer which is formed is called Helmholtz double layer. So, because of this Helmholtz double layer, a potential difference which create is called electrode potential. Now, the tendency of electrode to lose the electron is called oxidation potential. The tendency of electrode to gain the electron is called reduction potential. So, if we write like for any metal M, which will give you Mn plus n electron. So, if we write the potential like this, E naught or E M to Mn plus n, that is metal it form Mn plus by losing an electron. So, it means this is a oxidation potential. And if, so let for this reaction, notation is like this, E naught Mn plus n, that is Mn plus it form M, that is by gaining the electron. So, this is reduction potential. It means when you do the numerical, please check whether the reduction potential is given or oxidation potential is given. Now, next is we can't determine this oxidation or reduction potential independently. It means the reaction, in reaction, the reduction and oxidation occur simultaneously, and that is why for a reference many electrodes are used, and very common electrode is standard hydrogen electrode. in this standard hydrogen electrode, there is a platinum wire and at the end there is a platinum foil, and this is covered with a glass, and hydrogen is passed for a standard condition at 1 atmospheric pressure, and this electrode is dipped in 1 molar HIN solution. So, if a standard is given, it means both HIN and H2 is 1, that is at 1 atmosphere and 1 molar concentration. And in this hydrogen electrode is very useful because in each and every temperature or condition, its reduction or oxidation potential is always 0. And when it is connected with another electrode and which has more reduction potential, then it will act as a anode. And if this electrode is connected with another electrode which have less reduction potential, then this will act as a cathode. So, there is a major problem how we find whether the reduction or oxidation take place. So, now in a simple way, there is 2 reactions, suppose A, which will give you A plus plus 1 electron, this is oxidation reaction, and suppose this B, which will give you B plus plus 1 electron, and this is again oxidation reaction because of loss of electron. If there is any confusion, please remember lone, and lone means loss of electron occur always in oxidation and at anode. And suppose oxidation potential is given, but generally in electrochemical series, we arrange the metal on the basis of their reduction potential in increasing order. So, it is easy or convenient to take reduction potential instead of oxidation potential. Let reduction potential, let this A plus A is suppose 0.34, and suppose for B its reduction potential is let minus 0.76. So, this is 0.34 and this is 0.76. Now, suppose I just find out that which metal or which is going via reduction process or act as a cathode and which will act as anode. To find this, let us compare the mathematical value of reduction potential. For A, the value is 0.34, while for B, its value is minus 0.76. So, it is clear that 0.34 is more than minus 0.76. That is, A has more reduction potential. It means the tendency of A is more to gain the electron. That is, A will act as a cathode. So, automatically the B will act as a anode. It means when we make a cell, we made the anode of B and made the cathode of A, and anode we write at left side and cathode we write at right side. Let us take another example. Suppose for metal Zn plus 2 electron, which will give you Zn, and copper plus 2 electron, this is copper. Its reduction potential is minus 0.76 and its reduction potential is always 0.34. So, here it is clear the reduction potential value of copper is more. So, when we make a electrochemical cell and which is an example of voltaic cell, then zinc will act as a anode and copper will act as a cathode. So, I think this is clear. So, now come to the point. So, in a standard hydrogen electrode, when we connect with copper, then it will act as a anode, and if we connect it with zinc, then it will act as a cathode. The standard means the activity of hydrogen and that of H plus both is 1. That is hydrogen, we pass the hydrogen gas at 1 atmospheric pressure and the concentration is 1. And for a standard condition generally we write E naught. Now, hydrogen electrode. A hydrogen electrode, the reaction is 2H plus 2 electron, which will give you H2, or H2 plus 2 electron, which will give you H2. Sorry, which will give you not this. Our second reaction is H2, which will give you 2H plus 2 electron. So, the hydrogen electrode, if we want to write oxidation reaction, then reaction will be this, and if we want to write reduction reaction, then the reaction will be this. And cell representation is platinum, H2 at a standard condition 1 atmospheric, and then H ion solution, and its concentration is 1 m. And when it is attached with copper, and since the reduction potential of copper is more than 0, then copper at right side means at cathode, it is at the cathode, and this at left side, it means this act as a, and this will be as a anode. And when it is written with zinc, then zinc it come to the left side and this it will come to the right side, because zinc its reduction potential is minus in minus, so it will act as a anode. So, with this we can find the reduction or standard reduction or standard oxidation potential. And here for this half cell reaction we can easily find the pH. Let for this reaction suppose E cell is equal to E naught cell, which is 0 minus 0.0591 log of, which is a Nernst equation we will discuss in next lecture, and log of product upon reactant, that is H2 upon 2H plus, and with the help of this we can find pH. So, we can with this we can find the H ion concentration of unknown solution, which is taken in a with a this electrode. But for redox reaction or for few metals, it is not used as a reference electrode. In that condition, some other electrodes are used, like a glass electrode or Calomel electrode. And for Calomel electrode, the reaction is basically Hg, Hg2Cl2, both are in solid, so solid, and then with KCl solution. And if we change the normality or concentration of KCl, the potential difference may also get changed. But generally here for 1 molar HCl, the potential is 0.268, while for saturated KCl solution, its value is 0.241, and which is term as known as a DC normal or saturated solution. In this Calomel electrode, there is a tube, and here Hg and Hg2Cl2 with KCl is there, and at the last there is a glass wool, and it is dipped in saturated KCl solution, and generally this is closed with a cotton, and at side there is a connector for the salt bridge. And this Calomel electrode, it generally it is used with a standard hydrogen electrode, and then pH of the solution, unknown solution, can be determined easily. And another is glass electrode, and which is a reference electrode also known as. And here when we put this electrode, or when the two solutions of different pH is used, so the potential difference will create, and this potential difference, it is basically we can find with this pH of the solution. Now, galvanic cell or voltaic cell, and in galvanic and voltaic cell, the zinc electrode is dipped in zinc sulphate solution, and copper electrode is dipped in copper sulphate solution. And since the reduction potential of zinc is less than reduction potential of copper, so zinc it will act as a anode and copper it will act as a cathode. And here at anode the reaction will be Zn, which will give you Zn plus 2 electron, and at copper the reaction will be copper plus 2 electron, which will give you copper. And the overall cell reaction, chemical reaction, it will be Zn plus copper plus 2, which will give you Zn plus 2 plus copper. And pure metals, they are in solid state, we put the activity or concentration 1, and for iron if the concentration is given, well good, and if not then we can put 1 molar. Now if we want to write cell reaction, so we know that at left side oxidation and at right side reduction. So here Zn solid, then electrode Zn plus 2, concentration which is given, let x molar, then salt bridge copper plus 2, now reduction, let y molar, it may be same or not, and then copper solid. This is the simple cell reaction of this galvanic cell. Now if come to the theory, so it is made up of 2 half cells. So oxidation occur at negative and reduction occur at positive. Salt bridge act to complete the circuit by joining the 2 half cell together. So simple. Now next is, what is the E0 cell? So there is lots of 3 or 4 formula to calculate this E0 cell, but just remember one formula. E0 cell is equal to E cathode minus E anode, but the condition is both should be in reduction potential form. There is some misunderstanding that at anode if oxidation occur, so here we have to write oxidation. So suppose you want to write oxidation, then the formula become E cathode plus E anode. So just remember only one formula and let E0 cathode minus E0 anode, but the condition is both should be in reduction form. So for galvanic cell, the reduction potential of copper, which is act as a cathode, is 0.34 minus the reduction potential of zinc is minus 0.76, and which is 1.1 volt. So the E0 cell of this galvanic or voltaic cell, and which is made from zinc and copper, is 1.1 volt. And since the E is in positive, that is E is greater than 0, so delta G, which is minus NFE, it will be negative, so the reaction will be spontaneous. And suppose for a cell if E is 0, E is 0 means the reaction is in equilibrium. If E is less than 0, that is if E is in negative, it means we required few energy for the reaction. Now salt bridge. We see here this is the salt bridge, and in previous diagram this is a salt bridge which connect the 2 solution. So the main function of salt bridge is to maintain the electrical neutrality within the electrical internal circuit. It helps in preventing the cell from taking its reaction to equilibrium, and if salt bridge are not taken or are absent, then the reaction will likely continue and the solution in one half electrode will gather a negative charge, and similarly on the other side it will accumulate a positive charge. So here the reaction it gets stopped, that is no electricity will be produced. So, at that time the salt bridge, it helps in preventing the accumulation of positive and negative charges around the respective electrodes and further allowing a smooth reaction to take place. So, the purpose of salt bridge is not only to move the electrons from the electrolyte, rather it is maintain the charge balance, because the electrons are moving from half cell to another cell. So, these three are the main function. First, it prevents the diffusion or mechanical flow of solution from the half cell to the another cell. It prevents or minimizes the liquid-liquid junction potential, and that is the potential which arises between two solutions when they are in contact with each other. The salt bridge acts as an electrical contact between two half cells. It maintains the electrical neutrality by providing negative and positive charges at the time of emergency. So, in which type of solution is filled in salt bridge? So, in salt bridge electrolyte, either KCl or KNO3 is generally preferred, is mixed with semi-solid solution which is agar-agar or gelatin solution. So, salt bridge, they are of two types, glass tube bridge or filter paper bridge. So, in glass tube bridge, it is an inverted U tube, and where these electrolytes are mixed in semi-solid form, but the condition is the mobility, that is migratory speed of both ions should be compatible or should be same. In filter paper bridge, they are another most commonly used bridge, and which consists of filter paper or porous material soaked in electrolyte. So, here NaCl or KCl are commonly used as a electrolyte, and these electrolyte concentration, porosity and roughness of filter paper affect the conductivity, and for higher conductivity a filter paper with smooth absorbent is used. So, generally KCl and KNO3, they are better inert salts, and inert salts are used from occurring because it basically does not react with salt or the solution. And KCl is very common because the positive ion and K plus ion and Cl minus ion, they have common diffusion coefficient for minimizing the junction potential. But KCl is unwise to use as an electrolyte when the electrode of silver or lead is used. Now, for this reaction, I think I have already discussed this, and when we calculate this, the E naught cell, it will become 1.1 volt. So, cell potential, so the simple formula, E naught cell is equal to E naught cathode minus E naught anode. Now, and please remember, E anode, it's a we know that at anode oxidation reaction occur, but if we remember this formula, E anode means reduction potential at anode. So, suppose there is one problem, calculate the potential of the cell, and the reaction is these two. So, first we compare the reduction potential. The reduction potential of silver, mathematical value of silver is more. So, this Ag electrode, it will act as a cathode because at a cathode reduction occur, and this copper, it will act as a anode. So, what will be the reaction of copper? The reaction of copper will be copper plus 2 electron. The reaction of silver will be Ag plus 1 electron, which will give you Ag. Now, the overall chemical reaction will be, now we multiply with 2. So, the overall reaction, it will be Cu plus 2 Ag plus, which will give you Cu plus 2 Ag. Now, what will be the E naught cell? The E naught cell will be E cathode minus E anode. Cathode is 0.799 and anode is 337. So, the value will be 264. So, answer is 0.462 volt. And since E is in positive value, so the reaction will be spontaneous because delta G, it will be less than 0. Now, here again calculate the free energy change. Free energy change delta G is minus NFE, and for this reaction is 2 Faraday 96500, and E is 0.462. So, we can calculate the value of delta G, which is in negative. So, the reaction is spontaneous. So, we will do this type of question in next lecture with Nast equation. Thank you.